So, locator sensitivity analysis. That is this button here. I'm going to pull this toolbar out. We put it down here in Advanced Analyzer Optimizer because it is an analysis tool. It essentially analyzes the sensitivity of your locating features. So what I want to do right now is I want to focus on just this knuckle. I'm going to go ahead and I'm going to deactivate all the moves except these down here. And you can see I'm simulating a tool over here. So what I want to do is I want to understand the multiple different geometric effects based on changing my locators. So if you look at this knuckle, it attaches here, here, and here. Well, I want to understand, does my variation get better or worse if I, made the location tighter? And that's what these moves are. So if I click over, you can see it's highlighting, and I drew some lines over here so that you could see the actual geometric area. So this is my original location method. This is location method number 2, location method number 3, and location method number 4. Now, those of you that are familiar with AAO, Advanced Analyzer Optimizer, you do not have to hit the auto generate. You just have to do a nominal build, and so now you can see all these different options are active, and it attached it to my tool over here. Now I'm going to hit Locator Sensitivity Analysis, and you will get this dialog box. What this is going to do is it's going to move all the target positions of the target points in each of the moves. It's going to move each point independently, plus or minus a ½ millimeter, and then it's going to look at the entire geometry of the part for its maximum amount of variation, both X, Y, and Z. So the first thing I'm going to do is just say calculate locator sensitivity. Now this takes a little bit of time because it's got to take each move point and move it to its plus and minus 0.5 position, and then look at all the mesh nodes on the feature to see what is the maximum amount of variation. And then it's going to do that for all 4 of these move types. So what this is allowing us to do is it's allowing us to analyze in advance, what if we modify our locators? What if we spread them out? What if we move a locator higher or lower? And I'm doing it specifically on an individual part, but we can do it on the entire system of the model. So if I turned on all these moves, I could analyze it, and it would tell us which move was most critical to my overall assembly. And as I'm trying to fill the time while this is calculating, so you can see this is the calculation time for just a knuckle. And this knuckle, has got some data to it, so the mesh on it could be quite dense. And, the more parts you have and the denser the mesh you have, the longer this is going to take. Once it's done, you will get some numbers here that's going to tell you the maximum overall variation caused by move number 1. And it's showing it in all X, Y, Z locations. So I can customize this. I don't know if it will let me do it while it's calculating. Oh, looks like I can. So here you can see, I can say, well, just show me the X variation, or the Y variation, or the Z variation. Generally, I just keep it on showing all the X, Y, Z's, and what it's going to do is it's going to root sum squared the X, Y, and Z for every mesh node and give you that overall variation. When we say show all X, Y, Z, you're only going to have one number in here. But what that number will be, it'll be the x variation squared plus the y variation squared plus the z variation squared, square root. Because that's how we give you a single number for the overall variation.